Dear children, today we will start with fifth chapter, Arithmetic Progression. When you read this name, you must be excited to know what is arithmetic progression. Children, in your daily routine, you must come across some pattern. For example, you start your tuition in the month of July from 1st of the month. So, if say that day is Monday, then children, Monday will fall on first. Your tuition day will be Monday, Wednesday and Friday. And if suppose you start your tuition on first, then Monday falls on third, then Friday falls on fifth, then Saturday and Sunday will be a off day. And then again you will go for tuition on 8th, then on 10th, then on 12th, and then again a gap of 2 days. Then you will go for on 15, then 17, then 19, and then again a gap of 2 days, and you will start on Monday on 22nd, and this pattern will go on. So what you have observed is that three numbers are falling at a gap of 1, that means 1, skip 2, then 3, skip 4, then 5, and now skip 2 numbers 6 and 7, you will get 8, then skip 1, 9, then skip 1, 12, and then skip 2 numbers to get the next one. So after every three numbers, you have to skip 2 numbers. So this is a pattern observed in this. Similarly, suppose there is a child who saves rupees 10 daily. So in his piggy bank, he is dropping 10 rupees daily. So that means first amount that he put in the piggy bank is rupees 10, again rupees 10, again rupees 10, again rupees 10. So that means every day he is following the same pattern, that is he is putting rupees 10 in the piggy bank. Maybe there is another child who is putting the money by increasing rupees 2 every day. So first day he started with rupees 10. The next day he'll be putting 12 rupees. The next day he will be putting 2 more, that is 14. The next day he will be putting 2 more, that is 16 rupees. Then next day he'll be putting 18, and then next day he'll be putting 20. Similarly, you all must have seen this ladder at your home, and you have seen that the last rag of this is lengthy in comparison to the other one. So if I start from the last, the length of the rag is 45 centimeter, then it is reduces to 43, then 41, and then 39, and so on. So similarly, children, if suppose there is some bacteria and the bacteria grows every day. First day it was 4, the next day it was 9, the next day it was 16, the next day it is 25, the very next day it is 36, and this is 49. So all of you all of us are able to notice that here it is the square of 2, then this is the square of 3, then this is the square of 4. So that means they are increasing in the squares of natural numbers starting from 2. So children, among all these patterns, you must have seen that there are few which are growing by adding the same number, we will get the next number. So children, see here in this this one, you are adding 2 every time, 10, then 12, then 14, then 16. So a particular number is added to the preceding number, and you are getting the next number of the series. So that number is 2. So if you are adding 10 to 2 to the first term, you are getting the second. If you are adding 2 to the second term, it becomes third. And if you are adding 2 to the third term, it becomes the fourth term, and the pattern goes on. It doesn't break anywhere. Similarly, children, in this you are decreasing by 2, so it is 45 centimeter, and when you are subtracting 2, you are getting the next number in the series. When you are subtracting further 2, you are getting the next number. Further 2 is subtracted, you are getting the next number. So that means either by adding or by subtracting, or we can say in this series we are adding plus 2, and in the other one we are adding minus 2. So the same number is added and we are getting the next term of the series. Then such series are called APs. Arithmetic progression. Succeeding terms are obtained. Succeeding means the next term. The next term is obtained by adding a fixed number to the previous term. So such a series is known as AP. Now children, there are a few examples of AP I have written. 1, 3, 5, 7, 9. That means odd numbers, if I write, it will always frame AP. Similarly, if you will write even number 2, 4, 6, 8, and so on, again the next number is obtained by adding the 2. Every time, therefore, even numbers and odd numbers, they fall in the um, series, of AP. And then children, uh, this is 100, 80, 60 and 40. So every time you are able to notice a fall of 20. That means D is common difference. That means common difference. The number which is subtracted every time or added sub every time is known as common difference. So what is subtracted every time is 20. Therefore, the common difference is 20 and it is maintained throughout. Therefore, we can say that this one is also an AP. Similarly, when you move on number line, you will see if I start from -3 from the left hand side, it is -3, then this is -2, then this is -1. Every time you are increasing by 1. So by adding 1 to the previous, you are getting the next term. Therefore, this is also an AP. Similarly, children, if you will write down the multiples of 5, 5, 10, 15, 20, 25, multiples of any number or always form an AP because they are increasing by 5 only. Every time they are increased by 5. So if you are adding 5 to the previous, you are getting the next. If you are adding 5 to this one, you will get the next. So such sequences are known as AP. Then similarly, here you are able to see that this is 1.2. If you will reduce 0.2, you will get 1. Further, a reduction of 0.2 will give 0.8, 0.6, 0.4. So this pattern is maintained throughout. Therefore, this one is also an example of AP. Now there are few terms that you need to understand the arithmetic progression better. So these notations are A. A is the first term of the AP. Suppose I have an AP 8, 1, 3, 5, 7, 9. So the very first term of an AP is always represented by A. So what is A here? A is 1. Common difference is the difference that is common between any two consecutive terms. That the number that you are adding to get the next term is known as common difference. So children, you can see it. If you are adding 2 every time, you are getting the next term. And if you will find the difference between the two consecutive terms at any instance, you will find that you are getting the same number. So if from the second term, I'll subtract the first term, I'll get A2 minus A1, that is 3 minus 1, and this is 2. And if I check this at the end, then also I'll be getting the same. So A5, if I'll subtract A4 from A5, any two consecutive terms, if you will check the difference between any two consecutive term, so succeeding minus the preceding, you will be getting the same number, and this number is known as common difference. Two more things you need to learn: what is n and what is the nth term of an AP. Now children, listen. Suppose there are few students and they are standing in a queue. Suppose at first place I have Ram, at second place Radha is there, at third place Rima is there, and at fourth place Raja is there. Now I'll ask two questions to you that will clear your doubt to understand what is n and what is the nth term. Suppose I'm asking what is Rima's number in the queue. So children, you will give me that Rima is at third place. So n is the place at which Rima is standing. You will count from the very beginning, first, second, and third. So she is at third place. So that place at which Rima is standing is called the n of N for Rima. But if I ask who is at third place, now you will give me the name of Rima only. Let's understand this thing by numbers, a sequence which has numbers in it. See, so this is 2 and then I have 5. Then since I'm taking a difference of 3, that means the next number in the series will be 8. The next number in the series will be 11. The next number is 14. The next number will be 17, and so on. Now, if I ask which number is there at third place, so your answer will be 8. So I'm giving you the place and you are giving me the answer who is standing at third place. Who is standing at third place will always give you AN. Who is at third place will give you AN. Therefore, AN is 8. But at which place 8 is? At which place in this sequence 8 is? Now your answer will be third. So that is N. So children, I hope you are able to understand. If I ask the place at which a certain number or a certain person is standing, that will give you N, but who is at that place will give you AN. So what is, suppose the teacher instructed you to stand roll number wise, and if I ask what is your roll number in the class, then children, you will tell me that you are roll number 40. If you are giving me roll number, you are roll number 40, that means this is N. If I am asking who is roll number 40, and your answer, whatever is your answer, will be AN. That means 40th प्लेस पर कौन खड़ा है वो AN है. That means who is at 5th place. 5th place पर कौन है. That means 14 is AN. 14 is AN. A5 is AN. 1, 2, 3, 4, 5. 5th place पर 14 है. So A5 is 14. But what is the place of 14? At which place 14 is? Then it is 1, 2, 3, 4, 5. Then 5 is the N. I hope children you are able to understand this. The difference between N and AN plays a very major role. Sometimes the children get confused and the whole chapter get finished, but the children are not able to understand what is N and AN. So work on it. Try to understand the difference. Now children, this is another AP 2, 4, 6, 8, 10. Let's observe the pattern. First term in this is 2. This is the first term. The second term, A2, the second term, what is at second place? Second place is 4. What is at third place is called A3. So 6 is at third place. A4, what is at A4? So that is 8. So here n is 4, but who is at fourth place? 8 is at fourth place. So that means this is an. Now children, observe this thing. The first term is always represented by A. Here the first term is A, and if I want you to calculate D, you will always calculate the difference between the two consecutive terms. Therefore this is 4 minus 2, that is 2. So you have seen the second term is observed by adding common difference in the previous one. So the previous one is A1 plus D, the common difference, will give you the next term. That means 4 is obtained by adding 2 to the previous term. This is the first term, 2, and I'm adding 2 to it. So I'll be getting the next term. Now, third term. Third term, if you want to get the third term, so you add 2 to the previous term. So common difference is added to the previous term and you get the next term. So if you want to get the fourth term, you will add 2 to the previous term. So this is the fourth term. Now you will add D in the previous term. Now children, let's simplify it further. A1 is equal to A. A2 is A1 plus B, but A1 is always equal to A. So in place of A1, I can write A plus D. Now what is A3? A3 we will obtain by adding D to the second term. And what is second term? Second term is A plus D. So in place of A2, I'm writing A plus D, and that makes it A plus 2D. Now try to understand. If it is A1, then there is no D, 0D. And if it is A2, you are adding D to it. If it is A3, you are adding 2D to it. Following the pattern, you can write A4 will be equal to A plus 3D. So you have seen the coefficient of D. If it is first term, coefficient of D is 1 less than that, that is 0. If it is A2, the coefficient of D is 1 less than that, that is 1. If you are adding getting A3, the coefficient of D will be 1 less than that, that is A2. If you are calculating A4, the coefficient of D will be 1 less than that. Similarly, A5 will be A plus 4D. A6 will be A plus 5D. A7 is equal to A plus 6D. So, if I want you to write on the last term, A nth term, the last term sitting in this series, I can say that an is equal to a plus 1 less than the number I have here, the number n. So that means n minus 1d. So this becomes the formula for finding the nth term of NEP. Now let's see how this formula is helping us finding the missing terms. So suppose I have NAP 12, 15, 18 and so on up to 19. Children, what is A here? The first term is called A, therefore A is 12. What is D here? D is always calculated by the difference between the two consecutive terms. So it is A2 minus A1. That means 15 minus 12. So D is 3 here. Now my question to you is, how many terms are there? If I have written in the same manner till 99, how many terms? How many means I want to count how many terms I want to find n. So I want to find n at which place 99 is. So this question can be asked in 3 ways. Find n, how many terms are there, and 99 is at which place. So children, in all the 3 ways, I am asking you to find out n. Now I have a formula. An is equal to a plus n minus 1d. See children, there are 4 variables: a, d, n, and an. Check from your question. You must be given 3 information. If 3 informations are 3 variables are given to you, put their value in it and find out the missing one. So children, an, what is at the nth place? So that is 99. So an you will write in place of an. A is the first term of the series, so you will write 12 here. N you want to calculate, so you will copy it as it is. D you have calculated, it is 3. Put the values here. This step is very, very important. If you are able to fill all the things in this term, all the variables in this step, that means your understanding is perfect. Now children, only the calculation part is left. So you will first bring this 12 this side, subtract it from 99, you will get 87. Then 3 is in multiplication, you will bring this 3 down, and therefore after cancelling you will be getting 29. Bring this minus 1 this side, when you transport it will become plus, so it will be 29 plus 1, this will become 30. Be very careful, you should not commit any error. Errors will lead to the deduction of marks, children, so be very careful. So this is 30, that means 99 is at 30th place, or I can say that there are 30 terms in this sequence. Children, I hope you are able to understand. A, D, N, and An. To understand them better, try the question of exercise 5.1, wherein you will understand, you will check whether the given sequence is an AP or not. And in exercise 5.2, you will find out missing out of A, D, N, and An. All the best for the journey ahead. God bless you all.